we know. Okay.
Okay.
Yeah. Now, so let us start off with the subject. If you refer to the book, आपने tutorial में तो you must be told about it. But if you refer to your textbook, here chapter 1, chapter 2 and chapter 3. These three chapters we have already studied it in digital systems. You can have a quick look at these three chapters. Chapter 1 has Boolean algebra, then K-map simplification, combinational circuits, different types of flip-flops, excitation tables, sequential circuits, how to design sequential circuits using state tables, state diagrams, state equations and all. Okay, so entire topic of digital system which we had covered is summarized over here. Okay, so it is just a brief summary just for refreshing your concepts. If you want, you can refer to these topics. Chapter 2 is focuses on encoder, decoder, multiplexer, demultiplexer, which we had already studied. Those are combinational circuits with MSI and LSI available. Okay. After that, we here they are focusing on registers, register with parallel load. We had seen how to design different types of registers. We had seen how to design register using D flip-flop, using JK flip-flop. What is parallel load? Input that you provide to your register, all the input bits are together loaded inside the register. And when you were designing the circuit for register, recall the concept. You had placed an additional input which was known as load, right? So that was parallel load. Only if the load input is on, your data gets transferred inside your register. Okay, so this chapter 2 is on this we had studied bidirectional shift register with parallel load and all. That was our last practical number 10. Okay, ROM RAM we had studied. What is ROM? Decoder plus OR gate. Remember, you were asked to design circuits using ROM. You were asked to design circuits using PLA, right? So in PLA also we had seen how to minimize the circuit. So that was chapter number 2. Chapter 3 over here is your chapter number 1 in digital system. That was about numbers, number systems, conversions, R's and R minus 1's complements. Okay, addition and subtraction of binary numbers. So gray code and other codes which you had studied, alphanumeric code, error detection code, parity bit and all. Okay, so these three chapters are not included in our syllabus. We are not going to cover them again. We will directly be starting from chapter number 4, that is register transfer and micro operations. Okay, so today let us start off with this chapter. Any questions about the doubt in the subject that we are going to study? What is this? Why is it getting selected? Okay. Yes, so we are going to study first of all chapter number 4, which is register transfer and micro operations. See, first of all, when I talk about internal hardware organization of computer, what does internal hardware organization of a computer have? It has a set of registers. Okay, it has set of registers with different functions. Then sequence of micro instructions. Now micro operations we'll say right now. These are sequence of micro operations which are performed on the data which is present in the registers. Okay, whatever binary information is stored in the register, you will be required to carry out some micro operations. So that is sequence of micro operations. And last, you also need something to control. It indicates in which sequence the micro operations should be performed. So these three things are very important if you want to understand the internal hardware organization of any computer. Okay, you should be knowing what are registers, which are the different types of registers, what type of data is, how to store data in the registers, and when you have some data in your registers, which micro operations to perform on them and in what order. Okay, that is decided by the control. So let us now start off with register. First of all, we all know what is a register, right? What is register? Register is a memory element which can store n bits of information. These registers are generally designated using capital letters. Now we are going to study register in detail. Okay, we have seen how to design them using different types of flip-flops. Now we are going to use them. We are going to use those different types of registers. So they are generally designated by capital letters. Okay, when I write R1, R1 is a register. R2 is a register. What is the need of these registers? Do you know that? When you write a simple C program, you write like this: C equals to A plus B. What is this? This is an instruction. Okay, this is an operation. Now, how is this operation? How is this instruction actually going to execute? You must store the value. We say that we store value in variable A, but what is variable in hardware? How is it stored? It is stored in some register. Okay, this B is stored in some register. After you perform some micro operation on them, what would happen? That data is calculated and then it is transferred to another register. So here now we are not going to talk about variables, but we are going to talk about registers. Okay, and imagine that your registers is something which is storing data for you for carrying out any type of operation. Now, you'll be studying different types of registers. MAR, which is Memory Address Register. You'll be studying Program Counter, Instruction Register. When I call R1, R1 is a processor register. Okay, Dire will be seeing all these registers. What is the functionality of these registers in detail. Now, when I talk about register, arrangement of registers generally is carried out. It can be divided into different form of bits. Suppose I represent a register like this: 0, 1, 2, 3, 4, 5, 6, 7. So this is a register. This is one way of representing register. Okay, first of all, let me start off with this. This is your register R1. When I write like this 0, 1, 2, 3, 4, 5, 6, 7, it means this is an 8-bit register. It is a register which is capable of storing 8 bits of information. You can also represent a register like this. See, we are going to study how to design circuits. We are going to study hardware implementation as well. Okay. So here, when I write 0 to 7, again it means it is a 8-bit register. No need of representing each and every bit separately. When I write like this is a notation used for representing registers. This means this is a 16-bit register. Okay. Again, in some registers, you can represent it like this also. It can be divided into higher order register and lower order register. Now, what is higher order and lower order? Suppose I talk about program counter. It is a register. We'll see what is program counter. Program counter generally is used for storing address of the next instruction to be executed. Okay, abhi don't get confused about what is PC, what is MAR and all. We are going to study each and every register in detail. But first of all, we are just looking at how do we represent a register in this register language. Okay, so I can write this as PCL, PCH. Here 0 to 7, 8 to 15. So suppose it is a 16-bit register, okay, with 0 to 7 are lower order. This is lower order register. This is higher order register. Fine. So this is the way in which you can represent registers. Now let us move towards what is register transfer language. Now that we know what are registers, how to represent registers, next thing is we need to know what is register transfer language. First of all, for knowing what is register transfer language, we should be knowing what is a micro operation. Now, I gave you an example that in C language, we carry out our instruction like this. We write our instruction like this. Here, how many operations are we doing? We have one operation, that is addition, and the other operation is equal to, which is assignment operation, right? So here, for if I want to carry out this operation at register level, we call this as micro operation. It is an operation executed in the data which is stored at the register level. ये data कहाँ पे store होगा? This A and B are stored in registers. So whenever I carry out any operation which is stored on any operation on the data that is stored in the register, I call it a micro operation. Okay. So this micro operation is also termed as elementary operation. Basic operation. Okay, it is carrying whatever data is stored on the register, you're carrying out some operations on those register, and that is known as micro operation. There are examples of micro operation. We can, this add is in my example. You have clear operation, you will be clearing the register, whatever data is there in the register, clear. Okay, you have operation called shift. So these are some examples of micro operations. We'll be studying the basic micro operation set in detail. But first of all, you should be knowing what is micro operation. Okay. Now, let us come back to RTL, that is Register Transfer Language. What is Register Transfer Language? It is a symbolic notation. Symbolic notation for what? Whenever you are carrying out so many micro operations among the registers, right? So when you are describing these micro operation transfer, okay, the symbolic notation that you use for describing these micro operation transfers among the registers, it is known as RTL. You will need hardware circuit for carrying out this, and hardware circuit is nothing but your registers. Registers are hardware. You need some bus common level. We'll learn what is bus, but you'll need some kind of wires, right, for transferring one for data from one register to another. Okay, so this symbolic notation means sequence of operations. Now it can be like when I write C equals to A plus B, there are a number of operations involved in just carrying out this simple instruction. Like loading data from memory, you need to load some data over here, right? You need to put them in processor register. Usko process ye maine kaha, this R1 is a register, R2 is a register. What are these types of registers? They are processor register. Okay, so you need to put whatever data you have been you have loaded from the memory, you need to put them in processor register. Again, you need to carry out some operation, then you have to load back the data to some other processor register. Okay, so this is what you need to transfer that data back to another register. So what is this? Sequence of operations are being carried out. Okay, and these sequence of operations that you perform, that symbolic notation which you use for performing these sequence of operations is known as register transfer language. Okay. Now let us see register transfer. What is register transfer? How do I transfer data from one register to another? See, whenever I wish to say that I want to transfer data from one register to another, we symbolically denote it using a replacement operator. This operator which we use when I write like this, R2, R1. So this operator is known as replacement operator. Okay, and this replacement operator, what is the task of replacement operator? It is just transferring whatever data is there on the right hand side gets transferred to the source on the left hand side. Always you need, transfer to the destination on the left hand side. You also always need to remember that right hand side is your source register and left hand side is your destination register. You cannot make changes like this. मुझे R1 R2 में डालना है, तो I cannot write like this. You have to place R2 over here only. Okay, we cannot change the language on our own. Clear? So this is what I am transferring my data from R1 to R2, where R1 is my source register, R2 is my destination register. Clear? So this is one type of symbolic notation which we have studied in RTL, where we are using replacement operator. Now when we carry out transfer like this, R1, suppose R1 has data 1110. When you carry out the operation this, what would happen? This 0 will get transferred over here. So it's not necessary that your R1 changes. R2 has to change. Whatever data was there in R1 got transferred to R2. पहले R2 में जो भी हो वो replace हो जाएगा. Hence we call this as replacement operator. Okay. Now, so this is how data is transferred. But generally we know that we cannot transfer like R1, we are transferring data of R1 to R2, but this operation will not perform without a condition. Okay, every time हमेशा R1 R2 में डाल ही दो, ऐसा नहीं है. We always keep some condition. We always keep some control of R1 to R2. There must be some control element which is controlling this operation, right? Like if I can say like that, if let us take any control variable P. If P is 1, then carry out this particular transfer. Okay, so here, what is this? P over here, P is my control function. It is my control function. It is controlling my micro operation. Okay, so this control function, it is a Boolean function. It can either be 0 or it can be 1. If the value of P is 0, then this operation will not take place. But when the value of this is 1, then the operation takes place, right? So how to represent a control function used in our register transfer language? We simply write P colon R2 R1. What does colon over here mean? Whatever is there besides this colon, it means that is your controlling element. It is your control function. Only when the value of P is 1, this transfer will take place. Suppose I want to tell you that मुझे ऐसा करना है कि x और y, I have two control variables. Only if the value of x and y both are 1, this operation should take place. So what will you write? Tell me. What will you write over here? I have two variables x and y. Okay. If both the values of x and y are 1, then only I want to carry out this transfer. Yes, xy or x and y. Okay, but we write xy here. What does xy means? We know that this is an AND operation over here. AND operation means only if both the variables are 1, it would result in a 1. Okay, we will see how to design the circuit for it as well. उसको block diagram भी कैसे बनाते हैं हम देखेंगे. ठीक है, but for now, what would be my control function? It would be x dot y, right? So when we write x dot y over here, it means only when both the variables are 1, my operation would take place. So that is my control function. So if I want to represent this control function through notation, hardware notation, तो कैसे करेंगे? First of all, we know that this is my register R2. Okay. Excuse me. This is my register R1. I want my R1 to get loaded to R2. I do not know कि R1 कितने bits का है, R2 कितने bits का है. When you do not know how many bits are going to get transferred from R1 to R2, you simply place a N over here. Data bits. कितने bits transfer हो रहे हैं? N bits. I don't know what is N over here. Okay. अगर आपको पता है कि this is a 4-bit register, so what you will do is, you'll cut this arrow and write 4 over here. It indicates 4 bits. Okay. So here right now I'm writing N. Okay, so R1 gets transferred to R2, but now I also have a control function over here, right? So how to represent this control function over here? Can anyone tell me? This is my control circuit. It is controlling the transfer. Okay, its name is P. Can anyone tell me what will I do over here to the control function? Where will I connect it? I will connect it to the load of R2 register. You all know the purpose of load. We have already studied it in digital system, that every register has a load bit assigned to it. And what will this load do? Only if the value of load is 1, data gets transferred. So can I connect this P to the load over here? Yes or no? Right. So only if the value of P is 1, my data would get loaded to my register R2. Okay? अब आपको अगर वो XY वाला करना है तो आप XY इस तरह से आप इसके ये जो भी इनपुट है इसको कनेक्ट कर दोगे ऐसे. So this is what? If you look at your textual exercises, your first example is something like this only, where you are asked to represent a particular operation using block diagram of hardware. Okay, उसमें दो operations दिए हुए हैं and you are asked to carry out that task. Fine. So if this concept is clear to you, you'll be able to solve out those questions. 4.1, 4.2, सब ऐसे. ठीक है? चलो, now moving ahead. Yeah, first of all, when would this transfer take place? Let me go back to that figure. See, if this, we know that there is a clock pulse associated with each register, right? You also have a load signal. Initially, when the load is 1, okay, this is at time t1. This is time t2. Now, initially your load is 1. This is your clock pulse. Okay, initially load is 1. अब load इस point पे t1 वाले point पे 1 हो रहा है. Okay, अब यहाँ पे वो 1 हुआ. So this is, my load is high at this particular time. Now, when would your data be loaded inside the register? Your data would be loaded inside the register when this load goes from 1 to 0. Is particular duration at T2, clock is going positive and this load यहाँ पे इतने duration के लिए वो 1 है, वो जब नीचे जाएगा तो इस duration पे your data gets loaded inside the register. Okay, so don't make a mistake that at this particular time itself आपका load आपका data transfer हो जाएगा. Okay, timing control signals will be studying later, but you should be knowing this timing diagram as well. So when would your transfer occur? Your transfer would take place at this particular time. Okay, now so we saw what is register transfer. We also saw register transfer with a control function. Okay, now let us move ahead. Let me quickly go show you that book as well, and then we'll move on to the next bus and memory transfer. Okay. Excuse me. So we learned what are registers, what are micro operations, what is register transfer language, what is register transfer, what is replacement operator, how to represent any register transfer language through its block diagram. Okay, अब इसमें से कुछ रह गया हो तो वापस देख लेते हैं. Okay. Yes, register transfer language. This, I told you that internal hardware organization of a digital computer. And set of registers, sequence of micro operations, and you have some control. So if these three things together describe the internal hardware organization of digital computer. Okay, we learned what is register transfer language, symbolic notation which is used to describe the micro operation transfers among register is called register transfer language. You should be knowing these things. Okay, register transfer, I showed you how data is being transferred and the different block diagrams of register, how you can represent a register. This is normal register R, You are showing individual bits. You are just numbering the bits like this and writing 0 to 15. It indicates that this is a 16-bit register. Okay. We also saw control function. इतना पढ़ा हमने, ठीक है? Moving ahead, again here these are the basic symbols which are represented, which are used for register transfer. We have already seen this. Letters and numerals which we use are denotes a register. I can say R1, R2. Then I told you MAR, memory address register. If you want to fetch something from a particular location in memory, you use MAR. Okay, we'll be studying that. And parts of register, you can divide the register in higher order bits और lower order bits. आप 0 to 7 लिख सकते हो या L लिख सकते हो. L is lower order. Okay. Arrow is your replacement operator, and comma, it separates two micro operations. If I want to carry out two micro operations at a particular time, what I can do is I'll separate them through comma. Okay. Now let us move ahead. See, internal hardware organization of a computer can have number of registers. Register R1, R2, okay? यहाँ पे मेरे पास, suppose I have two registers R1 and R2. And you saw that when you want to transfer data from one register to another, you connect the two registers like this. Okay, तो इससे मेरा काम हो गया. I have 4 bits. I connected individually each bit to another register's individual bit, and I am able to transfer the data. What if I have 3 registers? क्या करना पड़ेगा? You connect R1 to R3. You connect R2 to R3. What would happen? Do you feel that this is feasible? Only for 3 registers, I had to create so many connections, right? If you connect each register to another, आपको क्या करना पड़ेगा? You will require lots of wires, which you don't think would be feasible, right? And in our internal organization of computer, we have so many registers, not only 3. 3 I have just drawn over here, but there are a number of registers inside my internal architecture. And then if I connect one register to another like this, in this way, using a mesh topology, this thing is not feasible. So for that, what shall I do? Right? So what we'll be doing is, we'll be using a common bus for data transfer. Suppose this is a common bus. All my registers are connected to this bus only. Okay, मेरे पास जितने भी registers हैं, मैं क्या करूँगी? All my registers are connected to this common bus. If you want to transfer data from A to D, what you do is you transfer A to D like this through the common bus. अगर A to B करना है, तो आप इधर से transfer करो. So the registers are not connected to each other. The registers are not connected directly to each other, but they are connected to from one to each other using a common bus. Okay, so now we will see how to design this type of bus system for 4 registers. Okay, वैसे तो बहुत सारे registers हैं, but if you want to design this type of register, this type of common bus for 4 different registers, how will we do that? Can anyone tell me which components would I need over here? मुझे एक रजिस्टर से दूसरे रजिस्टर में डेटा ट्रांसफर करना है. Can anyone tell me which component would I need over here? Which would transfer? See, I told you कि if I want to transfer A to D, right? I'll be transferring A over here और वो यहाँ पे ही जाना चाहिए, फिर वो B में नहीं चला जाना चाहिए. Did you understand? How would you get to know कि A वाला डेटा ही बस में आया? B का नहीं आना चाहिए, C का नहीं आना चाहिए. When you provide a proper instruction that transfer the data of R1 to R2, तो R1 वाला ही डेटा बस में जाना चाहिए. How to do that? Anyone who could give me some idea? Yes, gates, multiplexers, fine. You'll be using multiplexers. We know that if I want to carry out any type of selection, okay, you know that multiplexers are for selection. When I say that I want to transfer this, I want to carry out this operation, it means I want to select one particular register and only that data should go to the common bus. So what I can do, I can simply use a multiplexer. Okay, so how to do that? Suppose you have 4 registers like this. I will need 4 multiplexers. हम वो सीखेंगे पहले कितने रजिस्टर, कितने मल्टीप्लेक्सर, कितने बिट्स. ओके, व्हाट एम आई डूइंग राइट नाउ? यू जस्ट हैव अ लुक. नाउ we know that multiplexer has a single output. Okay, and I'll be using 4 cross 1 mux. Okay, 4 cross 1 mux. So how many selection lines would I need? 2 selection lines. Let these 2 selection lines be common for all the 4 multiplexers. If I select 0 0, what would happen? 0th bit of all the 4 multiplexers would be transferred to my common bus. Okay, ये 4 bit वाली common, 4 line वाली common bus है, which can store 4 bits. Okay, which can transfer 4 bits. I am drawing very dirty, but please bear with me. If I directly show you the figure, it would be, you will not understand that much. Okay, so I have a 4 line common bus. Output of each multiplexer is connected to that. Okay, now what I want to do is, I want to transfer only a particular register's data to my common bus. If I select 0 0, suppose these are my registers A, B, C, D. Okay, 4-bit registers. If I select 0 0, what should happen? Register A's data should be transferred to my common bus. Okay, so what we will be doing is, register A's data. Let us connect register A's data to 0th bit of all the 4 multiplexer. Did you understand what did we do? When I select 0 0, this is a 4 cross 1 multiplexer. Okay, so when I select 0 0, what would happen? 0th bit of all the 4 multiplexers would get transferred to my common bus. यानी क्या होगा? A का डेटा बस में चला जाएगा. Okay, how to store it in some other register, we'll first see that later. अभी पहले बस में कैसे insert करें, that you focus on. Okay, is it visible now? I have a next tute, so I started that meeting and it got changed. My screen got changed. Okay, similarly, what will you do? To the second bit of each multiplexer, connect B wala register. Okay, so all these are your 4-bit registers which has A0, A1, A2, A3. So all the 4 A1, sorry, A3, B3, C3, D3, you will connect to this multiplexer. A2, B2, C2, D2, you will connect to this multiplexer. Okay, so this is how you will design the entire common bus. And depending upon the selection line that you select, your data would be transferred to the bus. ये अच्छा सा figure देखो अब. Here you have 4 registers A, B, C and D. Each register is of 4-bit. Okay, and what will happen now? How are you connecting the multiplexers with the registers? How is this common bus connected? Here they have shown example of only the 3rd bit of each register connected to first multiplexer over here. ठीक है, मैंने आपको पूरा एक register करके दिखाया. Connect A0 to the first register, first multiplexer, A1 to the second, A2 to the third, and A4 to the, sorry, A3 to the fourth. So whenever you select 0 0 line, 0th bit of all the 4 multiplexer would be transferred to the common bus. Similarly, when you can select 0 1, तो क्या होगा? B0, B1, B2, B3 connect होगा. Look over here, B0, B1, B2, B3. Where do you have it? This is second pin of all the multiplexer. Okay, so B data would be transferred. When you select 1 0, this input of all the multiplexer would be connected to the common bus. So this is how internally data is transferred between registers. अभी तो पहले हम बस में ले जाएंगे, फिर हम common bus पूरा देखेंगे how when you have multiple registers connected to the common bus, how does actually data transfer takes place. Okay, so this is just a brief introduction about the bus system. In next class, we will also see one more alternate to this. How to carry out. अभी हमने ये क्यों सीखा? Because we are studying register transfer. Okay. How to transfer data between different registers. So that is carried out through a common bus. Okay, so in next class, I'll also show you one more way in which we can connect register. Instead of using multiplexer, we'll be using tri-state buffers. I had a plan of teaching this today itself, but somehow it got late. Okay, so that in the initial 2 to 3 minutes, I'll cover that, and then we'll be moving towards arithmetic micro operations. Okay, addition, subtraction, we'll be seeing the circuits which we already know, adder, subtractor circuits. Okay, how to carry out increment operation, decrement operation. So we'll see all the different micro operations, and then we will try to design one common circuit for a 4-bit arithmetic. We'll be designing a one common 4-bit arithmetic circuit in which you'll be able to carry out number of operations. Okay. तो इस चैप्टर में अब नेक्स्ट है अरिथमेटिक ऑपरेशंस एंड लॉजिकल ऑपरेशंस.